Sorry, I was about to walk in front of you.
All right. Does anybody have a question? I'm sorry. Any questions from homework stuff? Yes? 2.535. Okay. That was just me forgetting because it had been like 11 seconds. So that's the one about the rocket sections? Is that the one? Yeah. So this one says a rocket is divided into 3 sections. All right, the payload and navigation section and the top. So here's the rocket. All right. So the top is the payload and navigation. The fuel section in the middle. And then the engine at the end. This room sucks. Okay. So a picture really helps out on those problems where, you know, a picture makes sense. And this is definitely one where a picture makes sense. Oops, sorry, man. All right, we'll see if that works. So they say the top section is 1/6 the length of the bottom. So now I can write in words. I got a top section, I got a bottom section, and I got a middle section. The way that I'm doing this problem right now is the way you should do the problem, right? Did I worry about math at all yet? I said math words just a second ago, but I didn't give a shit about it. I said, oh, I see the names involved. Let me write those down in English. Now I'm going to start bringing the math in. Got a little picture for myself, even though, oh well, it's a safety cone rocket. I don't know. Now I worry about which one is, now what's my next step? Figure out
The rest of it.
Sure. I like that. Your next step is to finish the problem, Jeff. What's my very next step? Yeah, who's going to be just X or whatever letter I want to use. So the top, it says the top is 1/6 the bottom. The middle is 1/2 the bottom. Yeah, that was really in your face. Everybody depends on the bottom, so I better give that one a name. What do you want to call the bottom section? No way. Okay. I'll do the capital B because my lowercase b looks like a number. So the top section is 1/6 the bottom. How do I write that?
1/6.
Careful. 1/6 B. Oh, no, careful. It doesn't say 1/6 less than or something. It says 1/6 of it. What does of mean? Multiplication. So this will be 1/6 B. And then the middle is, I think it said, yeah, half the bottom. So what would that be? 1/2 B. It doesn't say 1/2 more. It doesn't. It says 1/2 of it, right? And that means 1/2 times B. And then it says the total length is 240 feet. So how do I get to 240 feet? What do I do with these guys? Add them up. I love it. Now some of you guys are gonna balk at the audacity of this problem having fractions in it, but just get over that shit, right? You're desperate. So I have to say this section plus this section plus this section equals a whole freaking rocket. So if you really, really, really hate fractions, you could kill them. Immediately, just kill them. Now, you guys don't do it correctly all the time. There's how many fractions are in this problem? 4. There's 1/1, there's 240/1. So if you're going to make LCDs, you better make every single thing have the lowest common denominator. Right? Like how would you do 3/4 plus 1/2? 3/4 plus 1/2. Times this guy by 2 to make it both have a 4. How would you do 3/4? Make a 3, Jeff. There you go, buddy. 3/4 plus 1/3. Multiply this one by 3, multiply this one by 4, multiply this one by nothing, multiply this one by 2, right? So how would you do 3/4 plus 1? Well, 1 is 1 over 1. So you still have to change the bottom there, right? Just because it's got a 1 on the bottom, we don't write it, but we better put it there so we don't forget. Oh shit, it's got a bottom. It doesn't not have a bottom, that's freaky. Just has a bottom we don't write, because divided by 1 doesn't do anything to it, but it's still something you have to worry about, right? So you could, right now, make every single one of these the same number. Or you could just combine these, right? I mean, which is really about the same work. To combine these, I have to make an LCD. I think this is where I'm going to stop. I want to actually leave something for you guys to do. So I would make an LCD and then get all my B's together. Because how would you solve, I'm not saying this is what it's going to come out to be, but how would you solve if it was 8/5 B equals 240? What would you do to both sides?
Multiply both sides by 5. I mean, divide both sides by 5.
Divide by 8.
Divide by 8/5, which is the same thing as multiplying by 5/8. Multiply by the reciprocal. I like it. I think you kind of talked yourself out of the right answer.
Yeah.
So do you understand, do you see once you get all these B's together, won't it look like this? Will it be this number? Oh, hell no. But won't it look like this, and won't you do the same thing to it? Okay. Is that cool for whoever asked that question? Who asked that question? Is that all right? Yeah. Okay. Anything else from homework stuff? I always get a little worried when there's not that many questions from homework. Yes?
Number 16.
Oh, yeah. All right. So, this is definitely a question that if nobody asks me about it, I get very concerned. This one talks about Robert drove on a level highway and then through the mountains. He's got a speed through the mountains, a certain speed, was slower than the first part of the trip. He drove 300 miles longer on the level. Yeah, and you start to read that and you're like, let me not do this one and see if he notices. But don't do that. What's the formula relating distance, rate, and time? Dirt. I love it. That's what I always said. Somebody stole that from me. Dirt, D equals RT. All right, distance equals rate times time. And we all know this intuitively. If you're going 80 miles an hour for 2 hours, how far did you make it? 80 miles an hour for 2 hours. 160 miles. Rate times time is distance. I love it. So that's going to be a big part of this problem. So what you can do, notice, do you guys see on number 60 how there's two parts to his trip? What are the two parts to his trip? What was this number again? 60? There's the trip through the mountains and the trip on the level highway, right? So level highway and then the mountains. So this kind of chart, this is the same thing the book does. You can look at the examples. There are a couple examples of this. And on the top, what I do for myself is I put the little formula so I know where to put you. So I just start filling in the boxes. It's a beautiful way to organize all the information. They give me a shitload of information. So what do they tell me? They tell me, what do I just know for sure? Yeah, nothing much. Yes, you do. First sentence, Robert drove for 6 hours on a level highway and then for 2 more hours through the mountains. Siri. Where's that? Okay, Google. What is that? I don't know. Whatever it is, shut up. So where do I put what?
Times 60. I mean,
So I got 6 hours on a level highway. So 6 under time for level highway. And then 2 more hours on through the mountains. I like it. See, so already it's not. Now, the rest of it's going to be unknown. It's going to be all related to variables. What is it they're asking me for? Some of you guys might not have the book in front of you. it says, if he drove 300 miles longer on the level road, blah, blah, blah. How fast did he drive through the mountains? We are nowhere near knowing. But since that's what they want to know, shouldn't I make that my variable? Right? So I want speed through the mountains is going to be my x, or that's one option. Kind of makes sense. Once I solve for x, I'll be done with the problem if I do that, because that's what they want to know. So where would I put that? Yeah, the rate through the mountains. Now what does it say else? It says his speed through the mountains was 20 mile an hour slower than his speed on the first part of the trip on the level highway. Now this is where things get a little freaky. Let me see if you guys can handle this. All right, there's two things I could do right now. Let me see if you guys are cool with this. His speed through the mountains was 20 miles an hour slower than his speed here. If I call this x, please get this. What would this be? Careful, no. His speed through the mountains was 20 less than this. If I called this x, this would be x minus 20. Right? This is 20 less than this. So this is 20 more than this. You ready? Stop, stop, stop. You ready? So we could do one of two things. Does everybody understand why I made this x? Because that's what they want to know. When I read the relationship, it says that the speed through the mountains was 20 mile an hour slower than the speed on the level highway. So if you do it the way you do generally word problems, you would have called this x. Why? Because the speed through the mountains depends on this. So I could just go back and do that. Right? If I do that, if I make the speed on the level highway, if I make that x, now what's the speed through the mountains is 20 less than that. X minus 20. Now, hopefully some of you guys understand. If I would have left this x, this would have just been x plus 20. If this is 20 less than that, that is 20 more than that. So you do have some flexibility in what you call x, to be honest. But if I just do it by the book the way we've been doing it, this is x because that depends on this. But if I'm like, I'm half as old as one of my colleagues, then they are twice as old as me. See, I can call either one of us x. Right? As long as I put 2 in one and 1/2 in the other, I'm okay either way. You guys kind of with me here a little bit? I mean, this is the next step up from just straight up by the book. Now here's where things get interesting. What do I put here? This tells me. What does this say to do? Multiply. So right here I'm going to put 6x. And right here I'm going to put, 2 times x minus 20. Where did I get that shit? Because I know that this is this times this, and I got these two filled in. So when you're going to do these distance rate time problems, you're trying to fill in boxes until you get a couple left open. How do you fill those last ones in? You do this. So this is a beautiful way to organize all the shit I know. Right? Like it. Why does this make sense? Because he went for 6 hours, and if I knew how fast he was going, I would multiply to get how far he went. Right? Now, what are these supposed to do? Now, if you don't have the book, you're all like, I don't know. It's a really good idea to bring the book. If he drove 300 miles longer on the level road than he did through the mountains. So this is 300 more than this. You see how I just basically said the equation in English, and I haven't even written the equation. This is 300 more than, let me make sure it goes, this is 300 more than this. This is, so what do I have so far? This is, sure, 300 more than, plus this. And then you can solve it. If you do enough of these word problems, you start to get the feel for, okay, here's the parts. Give them names. What do those parts do with each other? The 300 miles is what the parts do with each other. That's what gives me the structure of the equation. This distance on the level highway plus his distance, I'm sorry, in this case they gave us is 300 more than. So this distance is 300 more than the other distance. And now that I've given them math names, I can actually set up an equation. And now this should be the easy step, right? Solving that thing out. There are examples like that in the book that you can take a look at, unless you don't in the book. Then you get it from the library or the study center, or you go to the Pirate Bay for textbooks, basically. You know, download all kinds of PDFs and cheat your ass off. But don't do that. That's bad. I hate that you have access to the instructor solution manual everywhere, but that's so bad. It's like finding your Christmas presents early. It sucks. Feels good, and then it feels really bad. Anything else from homework stuff? Yeah.
Same chapter.
Oh, good. All right, good. This is a definite problem that if nobody asked me about it, I really doubt that everybody's got it. It's one of these freaky problems. This is the one about Jimmy Johnson.
Yeah.
Now that is the name of a race car driver, I tell you. I can say that because I'm from Georgia. So, this one is a little weird. This one says, at some point in this race, there's a lot of extra stuff they give you. I don't give a shit about the 3 hours, 23 minutes, 50 seconds. I don't give a shit about that. This one says, at one point, Johnson was 80 miles closer to the finish than he was to the start. How far had he traveled at that point? So what you've got to do that doesn't immediately come to everybody. Which one was this again? 12, thank you. Is you have got, here's the start, here's the finish. I know it's not really a straight line, but who gives a shit? From the perspective of the car, it's a straight line. Where is he in this problem at the snapshot this problem takes? He's 80 miles closer to the finish than he is to the start. So where would I put it? Over here. 80 miles closer to the finish than he is to the start. So probably a little more than halfway over there. Okay, so he's 80 miles closer than he is over here. This is 80 miles closer than this. You start to see what your variable is going to go. You actually have a choice here either way, but what two things do I not know? What are the players in this problem? This distance and this distance. So who are you going to call just X? I don't know why I just drew this again, but yeah, if you call this X, this one is 80 miles closer. So what would this be?
X minus 80?
Now, does it make sense to say X plus 80? No. Come on, you can do this. If this would, now listen. If he's 80 miles closer to the finish, if he was 300 miles away from the start, if this was 300, and he's 80 miles closer to the finish, what would this distance be?
220.
If he's 300 away from this, and he's 80 miles closer to the finish than he is to the start, not 320, 300 minus 80. He's 80 miles closer to the finish than he is to the start. Now let me say it again. You could do this. If you have 8 more apples than somebody else, right? So he is 80 miles closer to the finish than he is to the start. So if he was 300 miles away from the start, he must be 300 minus 80 away from the finish, right? If it's 80 miles closer, it's 80 miles less distance. That's what closer means, less distance. Is that better? So if this was 200, so if it's 300, that leads to this being 220. If it was 200, what would this be?
120.
120. What do you keep doing? Whatever this is, you subtract 80. So what is this? X. So what's this? X minus 80. Now how long is the whole track? 400 miles. It's called the 400 mile, whatever the hell. But yeah, they say it's 400 miles. So what's got to be true about this and this?
They have to equal 400.
Yeah, when you add them, you got to make 400. Now I will agree that that problem was weird. You would never really think to do this picture, but that's the purpose of this. Get creative with this. Draw a picture that helps you, right? And also, I understand, if you've never seen this before, you don't even think to do this kind of thing. So I don't blame you that much. But does it kind of make sense now? I want to give myself a really easy sketch. You don't have to draw a little race car and a track and then an audience. Unless you really want to. You're like, or you just do that for me. That's fine. I can't draw over shit, so I don't do that. I just make lines. I'm like little spider pigs. Okay. Anything else from homework? Okay. All right, so let's get back into where we left off. I'm pretty sure, yeah, let's do a couple of inequality problems. We haven't really done a full one yet. And then we're going to get into graphing. Graphing is normally the second most hated thing after word problems. Let's do some inequalities real quick. Let's just remember the basics here. How do I graph that? What does that say?
X is less than.
No.
X is greater than or equal to negative.
So which one's the less than? The less than is the one that looks like an L that's had a rough night, right? So doesn't that look like an L that just fell over a little bit? It's like coming in the door like this. So less than is the one that looks like an L that fell over a bit. So that is greater than, yeah. So how would I graph this?
-2.
Put a -2. Remember the symbol. What symbol do we put on there?
This can be a
Bracket. Oh shit. So if you weren't here yesterday, open circle is what you used to use to not include something. Now we use parentheses. And if I want to include, I use part of the I. I use a bracket. So I want to include the -2, right? How can I tell? Straight line. So one of my students said, if you see a straight line, you make a straight line like that. You don't finish the curving line. Is that, I mean, whatever the hell sticks in your head. It's just a symbol that means the same thing the circle is meant, but it's just a little more sophisticated. And of course, I drew it that way because I'm going to shade it which way. So I always think about, like, I don't know if you guys are going to appreciate this, but Dragon Ball, where they
Dragon Ball Z coming out.
Don't they always, isn't that always shooting out like that?
Yeah.
That's why you do this, because it's going to shoot that way. And there's Cell over here, and it just laughs. If you don't know Dragon Ball, you're fine. You don't have to know Dragon Ball. It's not a prerequisite. If you know Dragon Ball, have you seen Broly?
Yeah.
Very good. All right. Let's keep it there. Okay. Again, don't worry. If you don't know Dragon Ball, I won't bring it up too much. How would I do this one? Yeah, x is less than 0. Notice how, oh my god, you don't have to give me all this scale of shit. Just put the numbers you're interested in. Here's your 0. Which way am I going to shade? That way. It's pointing me the direction, right? It's pointing me that way. So which way, and what symbol am I going to use? Parenthesis opening which way? Kame. So it's got to be this way and shade. Now that'll stick in your brain if you know Dragon Ball. How are we doing so far? Is that all right? Even if you don't know Dragon Ball, I just open it in the direction I'm going to shade. That's all it is. Yes?
What does the include mean?
Include would be, I'm including -2 because it's allowed to equal -2.
Okay.
Yeah, so it's like when I used to put an open circle, a closed circle, like a shaded circle, yeah. One thing I forgot here, how do I make this into interval notation? Where does this go from to? -2 up to infinity. You put the same symbol there. What's infinity always get? Yeah. Parentheses. If you put a bracket on there, I want you to show me infinity, because you just said you can get there. If you include infinity, you can pick it up, show it to me. I want to see that shit. I think that's what was in the briefcase in Pulp Fiction. I don't know. Infinity. How do I do this one? Where does it go from to? Negative infinity up to 0. This always gets, and this is also going to get, because it's what's there.
I can have negative infinity. That's just nothing.
No, it ain't.
Same thing of having 0.
No, it ain't. Is -1 the same thing as 0?
Yeah, because you still ain't got it.
Yeah, but you owe it to somebody.
I'd rather have 0 as a debt instead of -1, right? -2 is even more debt. -3 is even more debt. So what's America going towards? Negative infinity, right? Bless you.
It's all a joke now.
Huh?
It's all a joke now.
Oh my God. Anyway, we won't talk about politics ever. Okay. So that's the basics. So let's try a real problem now. Because they're not going to look that nice.
What's the reasoning they switched to the brackets and parentheses?
Good, because you see how it goes right into interval notation. Much better now. Yeah.
How do you write the infinity?
Say again? Sorry?
The infinity.
It's an 8 that fell over. So what I always do is I start in the middle of it and go bam, bam. Right.
Circles.
You could just draw 2 circles next to each other. That'll work, right? All right. Let me see. What was it? Oh, I want an inequality. Sorry. Let me make this come out not too freaky. Yeah, that'll work. Okay. So everything solving inequalities is exactly the same as equations, except for when you multiply or divide by -1. We talked about that yesterday. We're probably not going to have to do that here because it's a positive there, right? So let's see. What's the first step then? It's the same steps as equations. Distribute. In my like terms. Yeah, 4x minus 5 greater than 7. That's 5. 4x greater than 12. Divide by 4. X greater than 3. Now you're at the point where you can do what we were talking about over there. So we have to understand that shit before we can do this. So take a minute and graph it and give me interval notation for this. When you're on, do it. You'll tell me about it. Do it.
Just like making sure, like if you were to divide by, I know it's a rule or something like that where if you divide or multiply by the negative.
Yeah, watch this.
Five,
This is
yeah.
so cool. Which one of these is bigger?
One.
1. If I divide or multiply by -1, the signs change, right? So which one's bigger now?
Two.
Sign flip.
Gotcha.
That's why. That's all it is. When I multiply or divide by negative, I change what side of 0 things are on. So I changed which one's bigger, which one's smaller.
Okay, I just wanted to make sure.
Yeah. All right, so how do I graph this?
Parentheses to the
Yeah, parentheses and then shade. Yeah. Now somebody's doing Street Fighter, right? Go to heaven. I remember. Played Street Fighter 1 way a long time.
parentheses. 3, comma, infinity, parentheses.
You. Right? Now right here, what was the principle we used right on this side, on this step here? What principle do we use here? I know it's a weird question, I don't care. Whatever you do to One side you do to the all the other sides. Yeah.
So for interval like notation, the like shading always goes on the infinity side.
Actually, the infinity is here because I shaded up.
Okay.
So there's no ceiling. There's a floor, but no ceiling. If I was shaded down, there would be no floor, but there would be a ceiling. Does that make sense? It is a weird way of looking at it. Right? Like here, there's a ceiling, but no floor. Right? In my day, you wouldn't have a floor.
So I guess that like my question would be, you always put the infinity sign where it's shaded.
So that, yeah, so the infinity sign is represented visually by the shaded arrow. Because what does that shaded arrow mean? Go forever. What's infinity mean? Go forever. I like it. So you can see the direct connection between the graph and the interval notation. I like it. So let's do one that's a little bit freakier that has to do with what I just said in a very strange way. Whatever you do to one side, you do to all the other sides. And we normally only have 2 total sides, right? So now let's have one that doesn't have just 2. Let's do one that has 3 sides. What do we got? Oh, we got time. Oh wait, I gotta actually make this happen. Don't write this down yet. Now you can't write it down. I'm not even gonna try to make it come out nice. Let's just see what happens.
Doing sevens next to those. My symbols up there, so.
I'm sorry. Gotta figure something out. Yeah, I started putting that little line through 7 a long time ago for me, because it does help. Alright, let's do this one together, because it's definitely weird. So obviously, what would I do first? Yeah. So I mean, the first few steps are the same as always. All this shit just kind of comes for the ride. Am I done in the middle yet? No. Let me just stick with you. So what do I get in the middle now?
14.
And what is always driving you? What's always motivating what you do? You're trying to get X by itself. That's all. You don't give a shit about that. You give a shit about that. You give a shit about all this shit that's here that with the X. You want to get rid of that stuff. So what do I want to get rid of first in here? 14. Beautiful. It's the same as always. Just when you go to subtract 14, you better do it to all sides. Left side, right side, inside. And quick side note. Maybe don't even write this down. No. 1 less than 2 less than 3, right? If I add 2 just to those 2, is it still true? No, I better add 2 to all of them, and then it's still true. That's all. You got to do the same thing to everything, or else it's not true necessarily. So let's see what we get here.
Negative 7.
-7. Those are dead.
Negative 3.
-3x.
Negative 2.
-2. And what's the last thing I need to do? Divide by -3. Which means what? Yeah, so this is 7/3 greater than or equal to. Why did I flip it? Because I divided by a -1, or negative number. So I got to flip these. Greater equal to x, greater equal to 2/3. Look how this makes sense. Isn't 7/3 bigger than 2/3? If you didn't flip these, you're saying 7/3 is less than 2/3. That's some magic shit. Right? Now, real quick, I don't like it like this. Let me just write it, and you see why it makes sense. I'm going to just mirror image everything, because now everything's in order. You see what I mean? Small to big. Just mirror image it. If that's bigger than that, then this is smaller than that. I can just mirror image that sucker. Because now everything's in order.
Is that something that you would want, like for tests and things of that nature, that we always make it go?
I don't care. I personally do it just because then I can see small to big. Because how does graphing and interval notation small to big, right? From your small to big. So I got to graph this. This is interesting. How am I going to graph this? What's another way to say this? All the answers are between. I can be between x. All the answers are between 2/3 and 7/3. Because now it's got a floor and a ceiling. Can't go below 2/3, and it can't go above 7/3. It's contained, right? So I put my 2/3, put my 7/3. What symbol is going to go on both of those? Bracket. So now it's like a little sandwich, right? And in the middle I put the jelly. There we go. Interval notation kicks ass on these. What's it go from to? We've said it a few times. 2/3 and 7/3, and what do you put on there? Same freaking symbol. Bam, bam. So little sandwiches are always nice. Yes?
I have a quick question. It says negative 2/3 up there, and then you went down.
Oh, negative divided by negative.
Oh, okay, that's fine.
Yeah.
Yeah, I understand.
I like
Thank you. But that wouldn't, I'm a little bit confused. Okay, so the way the notation at the bottom is made, it would make the pointing of the actual, the greater than or equal.
You ready? You ready? Here. Are these different? No. If x is bigger than 7, that means that 7 is smaller than x. That's what I mean by mirror image. So, if it's written like this, with the variable on that side, this will point me the direction to shade. This isn't written the right way. I don't always follow this. If I put the variable on the side, it points me which way to shade.
Gotcha.
So here, you got to read it this way. X bigger than 2/3. That's why from 2/3 I went up.
Okay.
X smaller than 7/3, so I went down from 7/3, and that's why it's in the middle.
Gotcha.
I like it. Good question, though.
So they're like doing that, like they're, you know what I mean, like because it looks like on the like arrows are pointing that way. I'm sorry, I'm just gonna,
No, it's the same question I think you had.
yeah, and I just
So
I
again,
just understand why.
how do you read this correctly? This is easy. X less than or equal to 7/3. This is why I shaded below 7/3, right? Read this the correct way. Read it backwards. What is X? X is bigger than
Oh,
2/3 if I read it the right way.
okay.
So that's why if I have this, it's easier to think of it as the answers are between these. Because isn't that what it says? If you try to break it down to looking at the inequality symbols, you're going to freak yourself out. Whereas really it's just the contain. It's containing that, right? Between 2/3 and 7/3. I like that. Containment wave. No. All right. A lot of Dragon Ball.
That's fine.
See, I'm doing a deep cut there. See, it goes back. Okay. All right, that's enough about inequalities. Let's get into some graphing stuff. Jaw. So the basics about graphing. So there's a urban legend. There's quite a few urban legends in math that would not make for a very good movie. But supposedly there's this guy. There's this guy named Descartes. Pretty obviously he's a French dude. He was sick one day, supposedly, looking up at his ceiling, watching a little fly walking along. He was imagining to himself, how can I tell the position of the fly? Yeah, he was feverish, so right, bored, obviously. But that's when he imagined the whole XY coordinate system, which is basically the same idea as latitude and longitude. So we can locate boats in the water, right, or people on land, or whatever, or GPS caching. So he came up with this idea. Now, so far, what have we been using? We've been using the x-axis to locate single numbers. But now, if I wanted to locate a position in this room, like somebody's position in the row. You guys with me? I'd have to be able to tell somebody how far to walk over and then how deep to go. So if I wanted to get to you, Wickham, I'd have to tell somebody how many rows to move over and then how many chairs to go in. That is 2 dimensions now, right? So I can't just use one dimension. I have to also, you can just go this way. I'm going to get to you. No, you have to be able to go that way too, right? So that's why Descartes said, all right, take the x-axis, it's beautiful. Don't mess with that shit, it's great. Just put another axis on top. So now I can locate every point on a plane. Now just to trip you guys out, I can add another axis coming out. Yeah, so then I can not just locate something, I can locate a point in the air, go this much over, this much in, and this much up. But let's stick to 2D, okay? So I'm not going to make you graph 3D. Oh my god, that'd be fun. So what is, somebody know what point this is right there?
0.
Careful, what point is this?
Y-intercept.
0, 0. Now, what does a point tell you? A point tells you how much to move on the x-axis and then how much to move in the y direction, right? So how much to move left and right. So if I don't move left and right at all, and I don't move up and down at all, I'm still right there in the middle. Anybody know what that point is called?
Point of origin.
The origin, I love it, because that's where you originate to find any other point. You start there and then you move around. So, for example, where would the point 2, 1 be? What does the first thing tell me always? It's alphabetical order. How to move in the x direction, how to move in the y direction, right? So it tells me to go start here, that's the origin. So you start here. Yeah, it tells me to go over 2, up 1. There's the point. Don't make a point here, that's crazy. Go over 2, up 1, that's the point. That's where like somebody's house is, right? My friend's house is right there. Or something. You guys kind of with me? Yeah. A little bit. So I can tell this is the same thing as telling somebody to go so many blocks over and so many blocks up. Same exact idea. I love it. So what point is this one?
Negative 2, 1.
Yeah, because I got to go back 2, up 1 now. Back 2, up 1. Does everybody see that? I mean, don't make more of it than it is. It's just, how do I get there? You go this much over, this much over. What about this point? Gotta be careful. Because what's the first thing I always tell somebody? How to move in the x direction. Do I want to move the x direction at all? No, I just want to go straight down. So don't move in the x direction at all and then drop 3. There we go. Now, somebody's from earlier, you can come in. What do you call that point specifically? The y-intercept. Why do we call it the y-intercept? Because it's the point that intercepts the y-axis. Ooh, we're creative. You guys feeling okay so far? How many, when I created this, how many sections did I create? 4. So these are quadrant 1, and then you would think we'd go up, clockwise, but we said, no. This is quadrant 2, quadrant 3, quadrant 4. Does that sound familiar? Those are the 4 quadrants. So some of the homework is going to say the point 2, 1. What quadrant is in it? It's in quadrant. What about this one? What quadrant is this point in?
4. No, it's on the y-axis.
I know I wrote the point, but there it is. So you'd say no quadrant. It's on the y-axis. I love it. So that problem is going to tell you. You can tell it which axis it's on or which quadrant it's in. How are we doing so far? Does this sound familiar? The last part is different, but you see how I made 4 pieces? I cut it in quarters. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. I like it.
Can
Yes.
you do another example?
Of quadrants or
Yeah.
points?
Quadrants and points.
Okay, all right. So what quadrant is this point in?
Second.
Yeah. Why? How would you get to that point? You would go,
Negative 5.
yeah, back 5
And up.
and up 5, right? So it's in quadrant 2.
Okay.
That's all. And what about? So this is in quadrant 2. Where would this point be?
Quadrant 4. Oh my bad.
That's right. Let everybody think for a second. Because where would I go?
11.
I would go 104 to the right and down 11. Do I even have to be able to plot the point to tell? No, I don't. I just know I go this way and then this way, so I must be in quadrant 4. I don't want to graph that point. I'd have to go outside. Right? Especially with my scale. Now my scale is by ones right now. Does it always have to be that? No. It can be whatever makes sense for the points you've got to graph. So if I did have to graph the point 104, I might want to go by, 50, 100, 150, maybe. So I can change the scale as long as it's consistent. If it's not consistent, you're basically lying to everybody, right? Yes?
Say if you had a problem and can your x-axis and your y-axis go by different numbers?
Totally. We see it all the damn time. I'm sure you've seen, it's like, here's 2009, 2010, and then the economy, 4 billion, or maybe even let's make it trillion, that could be like the debt, right? All right. So this is going by ones, ain't it? And this is going by 1 trillion, completely different scales. Thank God we're allowed to do that, because it's not lying now. You just got to be consistent. Now maybe a little bit better. Because I do have to, this is 1 trillion, and then another trillion would be 3 trillion, right? So your scale has to be consistent on that axis. The other scale can be whatever it needs to be, but it's got to be consistent. I like it. I like it.
Question.
Yes?
When graphing, so like, you see how you put the trillions up there, like writing that every time?
No. I mean, so you could just put, this is, you could label this as trillions,
Okay.
Yeah, you can label it, so I don't have to put it every time. I like it.
Put the little squiggly line.
Huh? Squiggly line? What squiggly line?
Between like 0 and...
Oh, yeah, the little heartbeat?
Yeah.
No. It's basically understood that you start with whatever that is. Because I don't want to go out 2009 just to get the graph started, right? I like it. Okay, maybe. Yeah, I could do one more thing, and then I'm going to unleash you on a little handout. Let's see. So here's where graphing becomes really powerful. Let me ask you, let me try this in this direction. Watch this. Let me give you a series of points. Can anybody predict, if I keep going in the same pattern, somebody predict what the next point will be? 412. I like it. What is the pattern that I'm doing? Adding 1, adding 3. What's a more direct way to say this? Every y piece is how related to the x piece? Every y piece 3 times the x piece. Doesn't that sound like an equation? Let me say it again. You got everybody cool with that? You guys see how to see that? Can you always see the pattern? No, but I'm kind of doing this backwards. I'm showing you points, and then we're going to write the equation of the line that would go through these points. Because that's all it really is. An equation of a line tells you how all the x's and y's are related to each other. That's all it does. Here I can see the relationship easy as shit. Every y is 3 times the x. That is the equation that would go through all these points, and obviously infinitely many more points. Are you guys semi with me? I mean, think of it just this way. Don't think about lines, don't think about equations. Doesn't this statement summarize the relationship between the y piece and the x piece? That's it. But then what do we do on top of that? We take Descartes' phi versus fly thing, and we use it to represent this equation visually, which seems to be a really smart thing to do. I mean, if I can see it visually, I can think of it in different ways. Maybe. I like it. So if I plot these points, where am I at? Okay. Let's do this. What kind of scale do you think I'm going to use on the y-axis? That's crazy. So, I don't really do that. And on the x-axis, I can just use by ones, right? Like you said. I love it. So then I can plot 1, 3, 2, 6, 3, 9, 4, 12. And at 0, what would it be? When x is 0, y is 0. Yeah, see? Just to put that in there. And then I can connect all the points.
970.
So whatever this point is here, its y piece will be 3 times its x piece. So think of it this way. How many answers are there to this equation? One answer, right? 3. How many answers are there to this equation? Infinitely many. So when I say list the answers to this equation, you go, sure thing, man, there you go. If I said list the answers to this equation, we got to start here, but how close am I to done? Because what about 1.0794? That's got an output. What about negative pi? Oh shit, that's got an output. What about 1,000,000,007? That's got an output. And all the numbers in between. So what's a better way to answer the question, what are the answers to this? Give them a picture. So what is the most fundamental thing about a graph? It is the answer to what are the answers to this equation. It's a visual representation of the answers to an equation. Does that make sense? If somebody's like, I don't want these answers, and I'm like, just go get your answer. Just follow the frickin' arrow. I'm done. Leave me alone. Maybe. So we're going to obviously focus on straight lines. You know, later this semester we're talking about curvy dudes, right? Because you got to be able to represent, roller coasters. Make sure the curve isn't too great so that nobody dies. Yeah, this is fun. We're all done. Right? So you can do some analysis for funkier things. But we're going to start with just straight lines. So let me give you this. We can at least get started on this. Where are you? Did I bring it this time? That would be so neat. Yes, I did. My colleague decided to leave some pink paper in the printer, so it's different for me, but oh well. You guys can get lucky and get some pink paper. So do the first two. Just do the first two. And we'll see how much time we got left after that.